So last time when we were looking at the for loop, I introduced functions, but I didn't spend a lot of time on them. So right now I want to just sort of head back and look at functions a little bit more. So functions allow us to group a bit of code together, and then we can just use a function call to run that set of code. It allows us to compartmentalize, so that means make different chunks of our program, so that in a more complex program, it's easier to debug because you can figure out which function is causing the problem. The other thing it can do is it allows us to reuse code. So instead of having to rewrite the same bits over and over again, we can call it multiple times in a program, and we can actually easily take that chunk of code out and use it again in a program when we might need it. So let's just take a little bit of a look at what functions are and how we get them. In all program languages, you need to make a definition. In Python, this is the way we do it. We just use the key def, and then give it a name. You always need to name it. And then you put a bracket, and inside the bracket, you put any sort of parameters that you need to give the function to run. So in this function, I'm just going to print out somebody's name. So whatever name I give the function called nameCall, it's going to print out hello and then that name. So if I want to call it, I can do just nameCall Jim, and if I run it, now I'll run the code in the nameCall and print hello Jim. The nice thing about this is I can do multiple name calls. So here I have a number of calls, and each call is going to name call, and then it's going to use all the different names that I put in there when I run it, so I'll get all of the outputs just with this one. In this case, it's not all that impressive because we just have a little short chunk of code. But if we go back to the function that I had the other day, which was to calculate the interest on a loan when we're compounding it, the calculate function had a little bit more of a little bit more to it. It did a little bit more. It calculated an interest and then told us the amount that we had. So when we end up running this function, we can call that calculate multiple times. And every time we call it calculate, it's going to calculate based on the parameters that we give it, which was the principal rate interest and time, principal interest rate time, and the compounding periods. So that way we were able to go forward and use it in a for loop. We were able to use it in a for loop to calculate for each of the months that it was running. We were able to calculate that given on that month. So that's one way we can use this. Anytime we're going to call the same thing over and over again, it can help to condense our code as well. The start, and you probably see it still running now. We had G code. It's a procedural language that is used by a few different types of devices. A lot of them are routers and printers, and it just tells the printer head where to go. And without using any sort of condensing, this runs. It takes a long time to run through. It's just running by and running by and running by. A computer can do this really quickly, so that's why it works for this, and it's a simple set of commands. But when you want them to be able to be debugged by people, you're going to have to change things a little bit so that they're accessible. And functions are a way we can do that. So I just want to look at a few other quick uses for functions here. Here's one way we can use functions too in a recursive way. That means the function runs through itself again. So I have a couple here, one for greatest common denominator and one for determining the factorial. So if we look at the greatest common denominator, I have a definition of the greatest common denominator giving me two numbers. First of all, it's going to print out those two numbers because I want those two numbers displayed for everyone. Then it does a quick, if the second number is 0, then the greatest common denominator is n. Else, we're going to send the numbers that we have back to this function using the modulus of n divided by m. And so it's going to keep running back through, and then when the remainder ends up being 0, then we have the greatest common denominator. So that's how we're going to run this. So if we run this, and I'll just uncomment this bit here. So running the greatest common denominator with the numbers 383 and 122, quickly running it, it tells me it tried 383 and 122, didn't get it, and the greatest common denominator ends up being 1. So greatest common denominator in this case between 651 and 33 is 3. In the factorial, so if you know what a factorial is, so if it's 5 factorial, it's 5 times 4 times 3 times 2 times 1. So we could do that with a for loop if we wanted to, but we can also do it here. If n is 1, then, if n is 0, so 0 factorial is 1, so we have to make sure we have that case. Otherwise, we're going to take the number and multiply it by the function minus 1. So what ends up happening is we keep feeding it back through this function. This isn't the best recursive one. If you get a really large factorial, actually you do want to do this a different way, because what ends up happening is each iteration of this program creates an instance, and then they get really large and you end up with an overflow or just a very, very long run. I'll show you here in a second what I mean. So print factorial 21, hit it here, factorial 21, there is the answer for 21 factorial. But if we start getting large numbers, so 210, I'll just add a 0 in here. We're getting big, but so you can put just factorial 10,000. Maximum recursion depth exceeded. There is a recursion depth of 1,000 set by default on functions in Python. There's a way to get around it, but for us, we don't really want to do that. So what we end up happening is, what we ended up getting here with 10,000 is it was just going through the iteration too many times. It reached a maximum and cut out. But this is another way we can call functions, because we have a function that within itself, it calls itself, and that's a recursive function. So going back to the basic working definition of a function, for a function, you need a name and a definition. You put the code inside that definition, and then to call that code, you use its name and give it any of the parameters that it needs. As you saw in the opening there, routers, or CNC routers, they'll often run on G-code. G-code is a sequential language. It just tells the positions and the depths. Well, that's part of the position, repeatedly for every single spot on the on any pattern that the router is trying to cut. So it tells its position and how fast it gets there. And as you can see, there's a lot of code for what ends up being not a lot of product. And the code will just keep running here. You'll see that it'll be running through pretty much the entire video here, just to show you how long it takes to do something that small. So we can apply this to a lot of machines. If we were going to give a machine instructions and we were giving it every instructions that we wanted to do, like in this small stacking machine that I have made up here, I'll just show a quick little video here. You'll see that for every move that we have to tell the machine every single move, one after the other, just like G-code. Over and back and picking it up and over and back. So to make a simple shape, it takes quite a few commands. If we were to give it a function, we could say something like write. And then the function will contain move right X number of times. So we're giving it the parameter X, and that will tell the machine to go right X number of times, however many times we tell it to. So here, if we give it write 6, instead of giving it 6 separate commands, each command being one move, we can give it one command that executes all the code in that function. So what I want you guys to do, we're just going to do a simple pen and paper task this week. After this, I expect you guys to use most of your code in functions. So instead of just writing a file, I want you to write whatever code you had in a function and then call that function in the file. So that's how I'd like your code structured from now on. To get sort of just to get a little practice, a little hands-on with this, what I want you to do is I'll give you some examples of some just like cup stacking, and I want you to, just like that machine on the little cartoon I had there, pretend that you're coding for it, and I'll give you a pattern for cups, and you're going to have to design the code. And I want you to do it both ways. I want you to do it explicitly, where every single command is given, and then I want you to turn those commands into functions, and then just call the functions that you need.